It's interesting that some people find science so easy, especially kids, some of them are just eat it up. And I don't know why it is. It's the same perhaps for all subjects. For instance, I lose a great deal of pleasure out of that. And I think people lose a lot of pleasure who find science dull. In the case of science, I think that one of the things that make it very difficult is it takes a lot of coffee or something. It's very hard to imagine all the crazy things that things really are like. Nothing's really as it seems. We're used to get, hot and cold, and all that hot and cold is the speeds that they're jiggling. If they jiggle more, it corresponds to hotter, and colder is jiggling less. So if you have a bunch of coffee or something sitting on a coffee, and the atoms are jiggling a great deal in the coffee, and they bounce against the cup, and the cup then gets shaking, and the atoms in the cup shake, and they bounce against the saucer, and the heat heats the cup and heats everything else. And hot thing jiggling a lot in the hot thing shake the ones that are jiggling only a little bit in the cold thing, so that the hot heat, we say, goes into the cold thing. It spreads. But what's spreading is just jiggling and irregular motions, which is easy to kind of understand. It brings up another thing that's kind of curious. That I say that things jiggle, and if you're used to balls bouncing, they slow up and stop after a while. But we have to imagine with the atoms a perfect elasticity. They never lose any energy. Every time they bounce, they keep on bouncing all the time. They don't lose anything. They're perpetually moving. And that the things that happen when we say something loses energy, if a ball comes down and bounces, it shakes irregularly. Some of them's in the floor. And then when it comes up again, it leaves some of those atoms moving, the jiggling. So as it bounces, it's passing its extra energies, its extra motions, to little patches on the floor each time it bounces, and loses a little each time until it settles down, we say, as if all the motion has stopped. But what's left is the floor is shaking more than it was before, and the atoms in the ball are shaking more than they were before. That the organized motion of all these atoms moving the same way, falling down, and the quiet floor is now transformed into a ball sitting on the ground. But all that motion is still there in a form, or the energy of motion, in the form of the jiggling of the floor, which is a little bit warmer. Unbelievable. But anybody who's hammered a great deal on something knows that it's true, that if you pound something and hit it a lot, you can feel the temperature difference. It heats up. It heats up simply because you're jiggling it. I find myself trying to imagine all kinds of things all the time, and I get a kick out of it, just like a runner gets a kick out of sweating. I get a kick out of thinking about these things. I can't stop. I mean, I could talk forever. If you cooled off the water so the jiggling is less and less, and it jiggles slower and slower, then the atoms get stuck in place. They like to be with their friend. There's a force of attraction, and they get packed like oranges in a crate, in a nice organized pattern, all just jiggling in place. If you're held at one end in a certain position, all the rest are lined up in a position sticking out, and it's solid at the end. Whereas if you heat that harder, then they begin to get loose and roll all over each other, and that's the liquid. And if you heat that still harder, and they bounce harder, then they simply bounce apart from each other. Their hands don't grab, so to speak, as they pass, and they fly apart again. And this is the gas we call steam. You can get all kinds of understanding when I was a kid with this air, which I was always interested in. It's just as if you had a ball that was trying to climb a hill and there was a hole it could go into, like a volcano hole, a deep one. It's rolling along, it doesn't go down in the deep hole, because if it starts to climb the hill and then rolls away again. But if you made it go fast enough, it'll fall into the hole. And so if you have something like wood in oxygen, there's carbon in the wood from a tree, and the oxygen comes and hits it, carbon, but not hard enough. It just goes away again. The air is always coming, nothing's happening. If you can get it faster by heating it up somehow, get it started, a few of them come fast. They go over the top, so to speak. They come close enough to the carbon and snap in. And that gives a lot of jiggly motion, which might hit some others, making those go faster, so they can climb up and bump against other and they jiggle, and they make mothers jiggle, and you get a terrible catastrophe, which is one after the other. All these things are going faster and faster and snapping in, and the whole thing is changing. That catastrophe is a fire. It's just a way of looking at it, and these things are happening. They perpetual. Once it gets started, it keeps on going. The heat makes, and so on. So this terrible snapping is producing a lot of jiggling. And if I put, with all that activity of the atoms there, and I put a cup of coffee over that mess of wood that's doing this, it's going to get a lot of jiggling. So that's what the heat of the fire is. And then, of course, if you see, this is what happens when you start to think. You just go on and on. Wonder where, how did it get started? Why is it that the wood's been sitting around all this time with the oxygen all this time, and it didn't do this earlier or something? Where did I get this from? Well, it came from a tree.